Bismillahirrahmanirrahim. I, Isha Mansoor, roll number 20, and my department is BS Biotechnology. I am going to tell you about the UV visible spectroscopy, which is submitted to Dr. Hammad Majeed. So, first of all, what is electromagnetic radiation? The electromagnetic radiation consists of discrete packages of energy which are called as photons. A photon consists of an oscillating electric field and an oscillating magnetic field which are perpendicular to each other. EM radiations. Frequency. It is defined as the number of times electrical field radiation oscillates in 1 second. The unit for frequency is Hertz. 1 Hertz is equal to 1 cycle per second. Wavelength. It is the distance between two nearest parts of the wave in the same phase, that is, distance between two nearest crust or troughs. The relationship between wavelength and frequency can be written as, and as photon is subjected to energy, so it is as electromagnetic spectrum. The electromagnetic spectrum of radio waves, microwaves, infrared radiation, visible light, ultraviolet, X-rays, and gamma rays are as following. The visible spectrum of ultraviolet 190 to 400 nanometer, violet 400 to 420 nanometer, indigo 420 to 440 nanometer, blue 440 to 490 nanometer, and goes on. The internal energy of molecules. Electronic transitions, UV X-ray, UV and X-ray, vibrational transitions, infrared, rotational transitions as microwave, and nuclear magnetic resonance. Interaction of EMR with matter. Electronic energy levels. At room temperature, the molecules are in the lowest energy levels, E0. When the molecules absorb UV visible light from EMR, one of the outermost bond lone pair electron is promoted to higher energy states such as E1, E2, and En, etc. Is called as electronic transition, and the difference is as 35 to 71 kcal per mole. Vibrational energy levels. These are less energy level than electronic energy levels. The spacing between energy levels are relatively small, that is 0.01 to 10 kcal mole. For example, when IR radiation is absorbed, molecules are excited from one vibrational level to another, or it vibrates with higher amplitude. Rotational energy levels. These energy levels are quantized and discrete. The spacing between energy levels are even smaller than vibrational energy levels. Electronic transitions. The allowed transitions are as following. Sigma and sigma excited transitions. An electron in a bonding s orbital is excited to the corresponding anti-bonding orbital. The energy required is large. For example, methane, which has only CH bonds and can only undergo sigma-sigma excited transitions, shows an absorbance maxima at 125 nanometer. Absorbance of maxima due to sigma and sigma excited transitions are not seen in typical UV visible spectra, which is 200 to 700 nanometer. N and sigma excited transitions. Saturated compounds containing atoms with lone pairs non-bonding electrons are capable of N and sigma excited transitions. These transitions usually need less energy than sigma excited transitions. They can be initiated by light whose wavelength is in the range 150 to 250 nanometer. The number of organic functional groups with N and sigma excited peaks in the UV region is small. N and pi excited and pi to pi excited transitions. Most absorption spectroscopy of organic compounds is based on transitions of Nr pi electrons to the pi excited state. These transitions fall in an experimentally convenient region of the spectrum 200 to 700 nanometer. These transitions need an unsaturated group in the molecule to provide the pi electrons. Selection rules of electronic transition. Electronic transitions may be classed as intense or weak according to the magnitude of maximum that corresponds to allowed or forbidden transition as governed by the following selection rules of electronic transition. Spin selection rule. There should be no change in spin orientation or no spin inversion during these transitions. Terms used in UV visible spectroscopy. Chromophore. The part of a molecule responsible for imparting color are called as chromophores. Are the functional groups containing multiple bonds capable of absorbing radiations above 200 nanometer due to N and pi excited and pi to pi excited transitions. For example, NO2 Auxochrome. The functional groups attached to a chromophore which modifies the ability of the chromophore to absorb light, altering the wavelength or intensity of absorption. Or the functional group with non-bonding electrons that does not absorb radiation in near UV region but when attached to a chromophore alters the wavelength and intensity of absorption. Absorption and intensity shifts. Bathochromic shift, which is known as redshift, when absorption maxima lambda maximum of a compound shifts to longer wavelength, it is known as bathochromic shift or redshift. The effect is due to presence of an auxochrome or by the change of solvent. Absorption and intensity shifts. Hyperchromic shift, which is known as blue shift. When absorption maxima of a compound shifts to shorter wavelength, it is known as hyperchromic shift or blue shift. The effect is due to presence of a group causes removal of conjugation or by the change of solvent. Hyperchromic effect. When absorption intensity of a compound is increased, it is known as hyperchromic shift. If auxochrome introduces to the compound, the intensity of absorption increases. Hyperchromic effect. When absorption intensity of a compound is decreased, it is known as hyperchromic shift. As you can see, the hyperchromic, bathochromic, hyperchromic, hypsochromic graph. Beer's-Lambert's law. Lambert's law stated that absorbance of a material sample is directly proportional to its thickness, which is known as path length. Beer's law stated that absorbance is proportional to the concentrations of the attenuating species in the material sample. Mathematical statement of Beer's-Lambert's law is where A is equal to absorption, E is equal to molar attenuation coefficient, path length, the thickness of the solution, and C is concentration of the solution. Derivation of Beer's-Lambert's law. Absorptions and transmittance. For transparent materials, where T is equal to 100%, for opaque material where T is equal to, for opaque materials the T is equal to 0%, and for the transparent materials T is equal to 100%. Lambert's law. Combining both laws, A is equal to ECL. Limitations of Beer's-Lambert's law. Deviations in absorptivity coefficients at high concentrations due to electrostatic interactions between molecules in close proximity, scattering of light due to particulates in the sample, fluorescence or phosphorence of the sample, changes in refractive index at high analyte concentration, shifts in chemical equilibria as a function of concentration, non-monochromatic radiations. Instrumentation. Spectrophotometer. An instrument measures the ratio of the radiant power of two EM beams over a large wavelength region. It utilizes dispersing element, prisms and gratings instead of filters to scan large wavelength region. Components. Source of radiant energy, collimating system, monochromator system, sample holder or container to hold sample, detector system of collecting transmitted radiation, suitable amplifier or readout device. To be continued as how it works and how it processes. First of all, the light source, then monochromator, prism or grating, then to the sample solution in, and at last digital display or meter. Light source. Light source of UV visible spectrometer should have following attributes. It should be stable and should not follow fluctuations. It should emit light of continuous spectrum of high and uniform intensity over the entire wavelength region in which it's used. It should provide incident light of sufficient intensity for the transmitted energy to be detected at the end of optic path. Types of light source: tungsten halogen lamp, hydrogen discharge lamp, xenon discharge lamp, and mercury arc lamp. Collimating system. The radiation emitted by the source is collimated, made parallel by lenses, mirrors, and slates. Monochromators. It is a device used to isolate the radiations of the desired wavelength from wavelength of the continuous spectra. Following types of monochromatic devices are used as filters, prisms, and the third one is gratings. Comparison, prism and grating. Comparison of prism and grating. Prism is made up of glass, which is visible, fused silica, which is UV, alkali halide, which is IR, and grating is made up of grooved on highly polished surface like aluminium. The working principle of prism is angle of incidence, and the working principle of grating is law of diffraction. The merits of prism are: prisms give non-linear dispersion, hence no overlap of spectral order. It cannot be used over consideration wavelength ranges. Prisms are not sturdy and long-lasting. The merits of grating are: grating gives linear dispersion, hence overlap of spectral order. It can be used over considerable wavelength ranges. Grating are sturdy and long-lasting. Sample holder. The cells are cuvettes are used for handling liquid samples. The cell may either be rectangular or cylindrical in nature. For studying UV region, the cells are prepared from quarters or fused silica, whereas color-corrected fused glass is used for visible region. The surfaces of absorption cells must be kept scrupulously clean. No fingerprints or blotches should be present on cells. Cleaning is carried out washing with distilled water or with dilute alcohol acetone. Detectors. Device which converts light energy into electrical signals that are displayed on readout devices. The transmitted radiation falls on the detector, which determines the intensity of radiation absorbed by sample. The following types of detectors are employed in the instrumentation of absorption spectrometer are as barrier layer cell, photovoltaic cell, phototubes, which is photoemissive tube, and photomultiplier tube. Photomultiplier tube: incoming photons to photocathode, window, diodes, anode, focusing electron, voltage dropping resistors, power supply, and output meter. Single beam UV visible spectrometer. Light from the source is carried through lens and arc through aperture to pass through a suitable filter. The type of filter to be used is governed by the color of the solution. The sample solution to be analyzed is placed in cuvettes. Double beam UV visible spectrometer. Double beam instrument is the one in which two beams are formed in space by a U-shaped mirror called as beam splitter or beam chopper. Chopper is a device consisting of a circular disc. 1/3 of the disc is opaque and 1/3 is transparent. Remaining 1/3 is mirrored. It splits the monochromatic beam of light into two beams of equal intensities. As you can see, the source, the monochromator, then chopper into sample, blank shutter, and then sample goes on to process with the mirror, semi-transparent mirror, detector, and then signal processor. Advantages of single and double beam spectrometer. Single beam: simple in construction, easy to use and economical than the double beam. It facilitates rapid scanning over wide Lambert region. Fluctuations due to radiation source are minimized. It doesn't require adjustment of the transmittance at 0% and 100% at each wavelength. It gives ratio of intensities of sample and reference beams simultaneously. Comparison of single and double beam. Single beam instrument. Calibration should be done with blank every time before measuring the absorbance or transmittance of sample. Double beam instrument calibration is done only in the beginning. Single beam instrument. It measures the total amount of transmitted light reaching the detector, and in double beam instrument it measures the percentage of light absorbed by the sample. Single beam instrument. In single beam it's not possible to compare blank. In single beam it's not possible to compare blank and sample together, but in double beam instrument, it's possible to do direct one-step comparison of sample in one path with standard in the other path. Single beam instrument. In single beam, radiant energy wavelength has to be adjusted every time. But in double beam instrument, in this scanning can be done over a wide wavelength region. Single beam instrument. Working on single beam is tedious and time consuming. But in double beam instrument, working on double beam is fast and non-tedious. So that's all about UV visible spectroscopy. Thank you.